Welcome to Lesson 7.6 of the Grant Architect course. In this lesson, we explore mixed methods design, the intentional integration of quantitative and qualitative approaches within a single evaluation study. Mixed methods. Evaluation has grown substantially as evaluators recognize that complex programs require diverse forms of evidence. Neither quantitative nor qualitative methods alone can answer all the questions stakeholders have about program effectiveness and implementation. Mixed methods provide more complete understanding by combining the precision of numbers with the depth of words. They can address both what happened and why it happened, both how much change occurred and what the change meant to participants. By the end of this lesson, you will understand the rationale for mixed methods, major design options, and how to present coherent mixed methods, evaluation plans, and proposals. What is mixed methods research and why has it become important in program evaluation? Mixed methods research intentionally integrates quantitative and qualitative methods within a single study, going beyond simply using both methods to actively combining them for enhanced understanding. The rationale for mixing methods includes complementarity, where different methods address different questions, triangulation, where multiple methods converge on consistent findings, development, where one method informs another, and expansion, where methods address different study components. These rationales justify the additional complexity of mixed methods. Key principles of mixed methods include intentional integration rather than parallel but separate methods, explicit rationale for why mixing enhances the evaluation, and clear procedures for how integration occurs. Simply reporting qualitative and quantitative findings in the same report is not mixed methods without active integration. Mixed methods requires additional expertise in both quantitative and qualitative traditions. Evaluators must be competent in methods they use, or must build teams with complementary expertise. Proposals should demonstrate this methodological capacity. Instrument selection and development significantly affect data quality. Poor instruments produce poor data regardless of sampling or analysis quality. Invest adequate time in instrument development or selection. Pilot test all instruments before full implementation. Train data collectors thoroughly on instrument administration. Monitor data quality during collection and address problems promptly. Validated instruments offer significant advantages but also require careful consideration of fit and appropriate use. Validation evidence demonstrates that an instrument measures what it claims to measure in specific populations and contexts. Common types of validity evidence include content validity, showing the instrument covers the intended domain, construct validity, showing the instrument relates to other measures as theory predicts, and criterion validity, showing the instrument predicts relevant outcomes. Reliability evidence demonstrates consistency of measurement across time, items, and raters. Using validated instruments strengthens your evaluation by building on established measurement science and enabling comparison with other studies using the same instruments. However, validity evidence from one population does not automatically transfer to different populations. An instrument validated with urban adults may not function the same way with rural youth. Review validation studies carefully to assess relevance to your context. Consider supplementary validation analyses with your sample. Common mixed methods design structure how methods relate. Convergent design collects quantitative and qualitative data simultaneously. Both are collected during the same phase. Results are compared and integrated during analysis. Explanatory sequential design conducts quantitative first, then uses qualitative to explain. Start with survey data. Follow up with interviews to understand survey results. Quantitative identifies what, qualitative explains why. Exploratory sequential design conducts qualitative first, then uses quantitative to test. Start with focus groups to identify themes. Develop survey based on themes. Test generalizability of qualitative findings. Embedded design nests one method within another. A primarily quantitative study might include qualitative component, or vice versa. Cognitive interviewing tests how respondents understand and process survey questions. Think aloud protocols ask respondents to verbalize their thought process while answering. Probing techniques ask specific questions about comprehension, recall, judgment, and response selection. Cognitive interviewing reveals problems invisible in standard pre-tests, including misunderstanding, difficulty recalling, and mismatch between intended and actual question meaning. Developing original instruments requires systematic processes to ensure quality. Begin with clear specification of the construct or domain to be measured. What exactly are you trying to assess? Literature review identifies how others have defined and measured similar constructs. Item generation creates a pool of potential items larger than needed for the final instrument. Items should represent the full range of the construct domain. Expert review by content experts evaluates whether items adequately cover the domain and are clearly worded. Cognitive interviewing with potential respondents reveals how they interpret items and whether their interpretations match intent. Pilot testing with a sample similar to the intended population provides quantitative data for item analysis. Items with poor performance statistics are candidates for revision or removal. Iterative refinement continues until the instrument performs adequately. Explanatory sequential design begins with quantitative data collection and analysis, then follows with qualitative data collection designed to explain or elaborate quantitative findings. Quantitative results inform qualitative design in this approach. Design features include two distinct phases, with quantitative preceding qualitative, typically greater priority given to quantitative methods, and mixing occurring when qualitative data collection is designed based on quantitative results. The goal is explaining quantitative findings through qualitative exploration. Implementation involves collecting and analyzing quantitative data first, identifying results that need explanation such as unexpected findings or variation across groups, designing qualitative data collection to address these specific questions, and integrating findings in interpretation. This design works well when evaluation centers on outcome measurement, but stakeholders want to understand why outcomes occurred. Quantitative findings identify what to explore qualitatively. Challenges include time required for two sequential phases and the need to design qualitative components after quantitative analysis rather than in advance. Proposals using this design must describe the quantitative phase specifically while indicating that qualitative components will be responsive to quantitative findings. Scale development requires attention to dimensionality and scoring. Unidimensional scales measure a single construct, while multidimensional scales measure related but distinct constructs. Factor analysis examines dimensionality empirically. Scoring methods should align with dimensional structure. Composite scores averaging across dimensions assume unidimensionality. Subscale scores preserve dimensional distinctions when appropriate. Observation protocols structure systematic data collection about behaviors, interactions, environments, or implementation processes. Well-designed protocols specify what to observe, how to record observations, and how to maintain consistency across observers. Observation targets might include participant behaviors, staff implementation practices, environmental features, or interaction patterns. Recording methods range from simple frequency counts to detailed narrative descriptions depending on evaluation questions. Structured protocols with predefined categories support reliability and quantitative analysis. Less structured approaches capture richer detail but require more interpretation. Observer training is essential regardless of protocol structure. Training should include protocol review, practice observations with feedback, and reliability assessment. Multiple observers should achieve acceptable agreement before independent data collection. Inter-rater reliability should be monitored throughout data collection with periodic checks and retraining as needed. Integration strategies connect quantitative and qualitative findings. Merging brings data together in analysis, compare themes from interviews with patterns from surveys, look for convergence and divergence, create integrated findings. Connecting means one data set informs collection of the other. In sequential designs, first phase informs second. Interview questions based on survey results. Survey items based on interview themes. Embedding places a secondary method in support of primary. A primarily quantitative evaluation might embed focus groups. A primarily qualitative study might embed surveys. Joint display presents visual comparison of both data sets. Tables or figures showing quantitative and qualitative findings together. Aid integration. Implementation logs capture what actually happens during program delivery. Staff record activities conducted, participants present, time spent, and observations about implementation. Logs provide data for fidelity assessment and process evaluation. Standardized formats ensure consistent recording across staff and sites. Train staff on log completion and review logs regularly to address quality issues early. Interview and focus group guides structure data collection while allowing flexibility for emergent topics. Guides are not scripts to be read verbatim, but frameworks ensuring coverage of key topics. Guide development begins with identifying the broad areas the interview or focus group should address based on evaluation questions. Within each area, develop specific questions that will elicit relevant information. Order questions to flow logically and build rapport before addressing sensitive topics. Draft probes and follow-up questions to deepen responses. Pilot test guides with individuals similar to participants. Revise based on what worked well and what did not elicit useful information. During data collection, use the guide flexibly. Follow participant leads when productive, even if diverging from the planned order. Return to guide topics to ensure complete coverage before concluding. Stories and statistics serve different purposes. Statistics tell you what happened and how much. Numbers provide scope, scale, and comparison. They answer how many and how much. Stories tell you why and how it felt. Narratives provide meaning, context, and human experience. They answer why and what it was like. Together, they provide a complete picture of program effects. Statistics show the program served 500 people with 80% satisfaction. Stories explain what that experience meant to participants. Reporting benefits from both in final reports. Numbers establish credibility. Stories create engagement. Together they make reports compelling and complete. Record review abstracts information from existing documents rather than collecting new data. Common sources include program records, medical charts, administrative databases, and participant files. Abstraction protocols specify what information to extract and how to record it consistently. Reliability between abstractors should be established and monitored. Incomplete or illegible records create missing data requiring documentation. Administrative data offer evaluation opportunities but require understanding of data systems, definitions, and limitations. Common administrative data sources include service records, enrollment databases, attendance systems, financial records, and compliance documentation. Advantages include low cost since data already exist, large sample sizes, and longitudinal coverage spanning program history. Limitations include data being collected for administrative rather than evaluation purposes, variable data quality across time and units, and potential gaps in coverage. Before using administrative data, investigate how data are collected and by whom, what definitions and coding systems apply, what quality control procedures exist, and what known limitations or problems affect the data. Linking administrative data with primary data collection can leverage strengths of both sources while compensating for respective limitations. Common mixed methods. Mistakes undermine evaluation. No integration means doing both methods but not connecting them. Simply reporting quantitative and qualitative findings separately is not mixed methods. Integration is essential. Weak component means one method done poorly. If qualitative work is sloppy, mixed methods is weakened. Both components need quality. Imbalanced resources means under-resourcing one method. If you budget well for surveys but not for interviews, interview quality suffers. Resource both adequately. Unclear rationale means no clear reason for mixed approach. Why use mixed methods? If you cannot explain, reconsider. Mixed methods should be purposeful. Translation and cultural adaptation of instruments require more than literal translation. Conceptual equivalence asks whether constructs mean the same thing across cultures. Some concepts may not exist or may differ substantially in meaning. Assess whether the construct is culturally appropriate before translating items. Translation processes typically involve forward translation from original to target language, back translation from target to original to check accuracy, committee review comparing translations and resolving discrepancies, and cognitive testing with target population members. Adaptation may require modifying examples, response options, or item wording to fit cultural context. Document all adaptations and their rationale. Consider whether adapted instruments require new validation rather than assuming equivalence with the original. Validation in the target population establishes whether the adapted instrument functions appropriately. Here is a practical exercise to apply what you have learned. Step 1. Identify evaluation questions that would benefit from mixed methods. What questions need both numbers and stories? What would each method contribute? Step 2. Select appropriate mixed methods design. Would convergent, explanatory, sequential, or exploratory sequential best fit your questions and constraints? Step 3. Plan quantitative and qualitative components. What survey would you use? What interviews would you conduct? How would each be designed? Step 4. Describe how you would integrate findings. How would you combine quantitative and qualitative results? What integration strategy would you use? Let us summarize the key points from this lesson. Mixed methods combines quantitative and qualitative approaches for more complete understanding. Neither method alone captures the full picture. Together, they compensate for each other's limitations. Designs include convergent, explanatory, sequential, and exploratory sequential. Each structures the relationship between methods differently. Choose based on your questions and constraints. Integration is essential because methods must be connected, not just parallel. True mixed methods synthesizes findings from both approaches. In our next lesson, we will explore the evaluation matrix, focusing on how to visualize the links between objectives, indicators, data sources, and timing.